Hello, everyone. Fro here. Welcome to our lecture for today. Today, we have a really fascinating topic. We're going to talk about hashing, hashing in computer science. What is hashing? Why is it relevant? And as a computer scientist, a computer science student, hashing is something you definitely want to pay attention to and might run across in different areas. So, we're going to dive right in. We're going to look at what hashing is. We're also going to look at some use cases where hashing is applied. And then last but not least, we're going to give some examples of some hashing functions and some characteristics of hashing, why this is relevant in the industry. Now, we're going to dive right in on what hashing is. So, what exactly is hashing? To define this simply, hashing is a way of scrambling information. So, what hashing stands for is to take some form of information and to scramble it. And the goal for scrambling information is to make it irreversible. So, you want to scramble information in a way that is irreversible. And I'm going to break this all down with examples to really give us a sense of why this is relevant. So, let's just take a simple example here. If you think about something that we can all relate to, we might all have come across is the idea of the egg. So we know there is chickens or birds do have eggs, and for that egg to become a chick of some sort, I'm gonna try to draw a chick here. For that egg to become a chick of some sort, it needs to go through a process of what? Hashing. So that egg has to hash and it becomes a chick. So this process is not something that's new. Now, I don't know if the term hashing came from this, it's motivated by this, but you can see where the analogies are. So you have on the left side here an egg, on the right side here you have a chick, and there is a process that egg goes through to become a chick or to become a chicken. Now, what are the characteristics of this hashing that the egg goes through? Number one, it's irreversible. It's irreversible. We can all agree that this process is irreversible. There's no way you are going to take a chick and somehow get back the egg from that chick. It's just not gonna happen. Biology doesn't allow that. So a key characteristics of a hash in this perspective is that it's all irreversible. It's irreversible. Now, what is another characteristic of this? If I gave you um, if I gave you a chick and say, hey, take this chick on the left side and give me an egg, you cannot do it. Okay. And the second idea is if I gave you a chick and gave you a bunch of eggs, so there are a bunch of eggs here, and I gave you this chick and say, which which egg did this chick come from? You cannot tell. Okay, so it's truly scrambled. There's no way for you to either go back or to even identify what egg or what where that information came from. So this is just a little motivation for us to understand the idea of hashing. Now, in computers, so if we go back to our world of computers, which is what we love, and we say, what is hashing in computers? And we want to define what hashing in computer is. Now, we're not dealing with eggs and chicks here. We're going to be dealing with what? We're going to be dealing with data. We're going to be dealing with data of some form or some input. So in this case, what we're going to say is a hash is something that takes an input data or some input of some sort, and you can send it through some function, and this function will be your hash function. And out of the hash function, we are going to get an output, and this output is called a hash value, or we call that a digest. Okay, I think I can't help but notice some of the food analogies there with digest and cheeks and all of that stuff. So, but that's beside the point. So, in computers, a hash, you have some input, you run it through some function, and you get a digest or you get a result. And there's a key characteristics that we cannot go back. Once you've gone through the hash, you're not going back. There's no way. Once you've gone through this function, if you think about the math, a function is f of x and the input is x and you get a result, you cannot go back. That's a characteristic of a hash. Now, what is a very simple example for a hash? So let's look at a very simple example. Simple example. And I'm even going to call this very trivial example because the example we're going to look at here is extremely trivial. Now, take the modulo operation in mathematics. The modulo operation in math. And if you have a bunch of numbers, so 1, 3, 4, 9, 11, 12, 13, even all the way to 115 or 2296, you name it. Take a bunch of numbers, any number you want. In math, there is this modulo operation that you can apply to this number to get some results on the corresponding side. And if we just went through this, a modulo operation is telling us in mathematics that if you have a number 1 and you do, let's say, uh, x mod 2, we want to do mod 2 specifically. So if we do mod 2 operation on these inputs, so these are the inputs here on the left side. So if we do a modulo operation on the inputs, what do we get in this case? So what is 1 mod 2? 1 mod 2 is 1. Because mod is basically a remainder. What is 3 mod 2? 3 mod 2 is, you guessed it again, 1. Because you have 2 and then 1 remains. What's 4 mod 2? 4 mod 2 is 0. 9 mod 2 is 1. 11 mod 2 is 1. 12 mod 2, 0. 13 mod 2, 1. 1 and 0. So you can see, in this case, the modulo operation takes some input and it maps that input to an output. So we have an input here on the left side and we're mapping that to some output on the right side. And the reason why we use this as an example for hashing is because it has the characteristics of a hash. It's a very trivial, no one is going to want to use this hash because there are definitely problems with it, but it's still a hash nonetheless. So let's see why this is a hash. Number one, it's irreversible. We talked about hashing being irreversible. This is irreversible. And then number two is, and this is actually a problem, there are lots of collision. And we're going to talk about why this is good and why this is bad. All right, so why is this irreversible and why are there lots of collision? So number one is irreversible in the sense that if I give you a number on the output, so on the digest, so this is the digest on the left side, on the right side, and then this is our input on the left side. So if I give you one of these digests and say, hey, tell me what number or what input led to this digest, you cannot. Theoretically, you just cannot. So if I just gave you one and say, hey, which input gave one? There's no way for you to realistically tell me because it could be 1, it could be 3, it could be 9, or it could be any odd number, right? Literally, any odd number will give you 1. Same thing if I gave you 0 and say, give me the precise input that gave us 0. There's no way because it could be any even number will give you 0. So in this sense, what we see is the hash function is irreversible. If you have the digest and you have the number on, or you have the output, you cannot go back to retrieve the input. The second, and this is a problem with this using modulo as a hash function. It's trivial. It's a quick thing to explain, but you're gonna run into lots of collision. And what does collision mean? It means if you have an input on this side, what you want ideally in a hash function is to have a unique output to the right side. But what we're seeing with this function is too many collision. As a matter of fact, half of the values will give collision because you have one on the left side and it gives you one on the right side. The same nine gives you one on the right side. So we are running into what is called collision in hashing, and that's a problem. And that's a problem. So just to kind of recap what we've seen here from the very beginning, what is hashing? Hash is basically a mathematical operation that you perform on an input to give you an output such a way that if you have the output, you cannot determine what the input to that was. And in the ideal world, with correct hashing, you want it so that one input can lead to one output. But as we've seen, there might be cases where your input different inputs can map to one output, and we call that a collision. That's a problem, and we're going to explain why that is a problem. So let's look at use cases to understand why collisions could be a problem in hashing, and that would kind of tell us and explain to us why we want hash functions where the inputs are uniquely mapped to the output. So what is the one common, let's use a smaller pen here. What is the one common use case for hash that we see? The very first area where you're going to see a lot of hashing being used is in websites. So, specifically, website password management. So, hashing is very relevant in this case. And let's explain why website developers or people who somehow would take your password want to make sure that that password is hashed so it becomes very secure. So, if we take an example of a user logging into their favorite website, your banking website, and you go to the website portal and you put in your information. And part of that information is going to have your password. So, what the developer of that website can do is they can simply take that password and they can, one, go directly to a database here and they can store your password. They can just take that password and store that password in the database, plain text. But if a developer does that, that is going to be a very, very big problem. Why? Because if you have a bad guy that's over here, some bad guy is sitting over on this side, and they somehow get access to that application, they can see all the passwords in plain text. And that's going to be a problem because you can just copy that and go logging into your app as any user, and no one is really going to approve of that. So the second alternative that developers or engineers would do is to say, hey, if you give us a password, instead of us just taking that password and saving it in a database as plain text, let's take that password. What we're going to do is we will run that password through some hash function. And once we've run the password through a hash function, that hash function is going to give us a value. And now we can store that hash into our database. And what that means is if we have a bad actor, again, on this left side, who somehow gets access to our database and they look for passwords, they cannot see the passwords. All they see is this hash value. Even if they grab the hash value and they want to figure out what the password is, it's going to be pretty tough for them to figure it out. Why? Because you remember, a hash goes one way but doesn't go the other way. So once you have a hash, if they want to say what password gave me this hash so I can use that password to log in, they cannot. They cannot figure it out. They cannot figure that out. Now, there are ways to figure it out. Let me not say they can never figure it out. There are ways to figure it out, but in theory, they shouldn't be able to figure it out if they have just the hash. All right. And so that's why in applications, in databases, people who build these applications always would want to use a hash function. So they would want to make sure that if the user is putting in a username or a password, they take that, they hash it. they have the hash out of it. They store that hash in the database. Now you might say, well, but how does the user log in the next time they come into that database? Well, when the user comes in the next time they log in, they simply come in as a user. Again, they put in the password, and all the app has to do is take that password, hash it, check against what they have in the database. So they're gonna hash this. Oh, let me actually do it in a different way. So they're simply gonna take that password that you put, and they're gonna hash that password. And when they get the result, they can just check that result to say, hey, do we have this result in our database? If so, then we know you've put in the correct password. If not, we know the password um, wasn't put. Okay. And the reason why you can do this again is because a hash guarantees that if you have an input on the left side, you would always have a consistent output on the right side. So if I had a hash for fru and it gave me, let's say, 56, and a hash for tech gave me 87, if I came back and I hash through again using the same algorithm, of course, you should always be guaranteed to get back this result here, 56. So a hash of an input will always give you a consistent result. So let's cancel this. Now we've seen the use case of hashing in password management, basically to make password secure. Now there are other things here that you can definitely do to make this even more secure than just hashing the password. There is sorting, which is adding random strings, and then there is peppering, and a lot of things that people do, and that will be a whole video in itself. But hashing is greatly used for websites. Anytime you log into a website and you put in your plain text password, to you, you're putting in a plain text password. But before it makes it into the application, some hashing algorithm is hashing that, and is doing a lookup against the database to say, do you have that data already, to confirm your identity. So if that database is ever breached or broken, in the ideal world, they should not be able to see the plain text password. Now, there are developers out there that don't do this, but just in general, that's something that most savvy developers will do. All right. The next example of hashing, and we're just going to touch on this really, really quick at a high level, is for integrity checks. And integrity checks. And this is relevant for think about files. Think about files, documents, etc. on the web. So if you go on a website and you're trying to download a document, how do you know that the document you've downloaded from that website is correct? Okay, so what happens is that document will be run through a hash function. So you take a document, so hash input, which will be your document, you run that through some hash function, and you get a digest of that document. Remember, you can hash literally anything, so you have a digest. So if you send somebody this document, this file, and they take that file and they run it through the same hash function, and their digest is the same, then they know that file hasn't been tampered with. But if they run it through a hash function and they all of a sudden get a different digest, then that's a problem. Okay, so hash functions are greatly used in integrity checks, especially for file transfers on the internet. Now, let's dive in and talk about some examples of hash functions that are out there. You might hear, or we've talked about hashing, but what are some of the examples of hash functions that you might find on the web? The very first one that we're going to talk about here is um, let's use a hash algorithms. You can call it an algorithm or a function. And on the right side here, we talk about the digest size. So a very, very common one, which kind of is getting older now, but it's still very common, is MD5. So MD5 stands for message digest. Okay, so we saw how we call the output the digest. So message digest 5, and that one uses 128 bits digest size. Again, one other characteristic to call out here from a hashing perspective is, as we saw, if you hash an input and you get an output, that output should always be consistent, and the size of that output will always be the same. So if I took an input, and I hashed it to get an output, and the output is of 6 characters, any input that I run through my hash should give me an output consistent with 6 characters. So that's one thing to know about hashes. So let's go back here to message digest. Message digest 5. Any input that you run through message digest would give you a 128-bit output. Okay, it's never going to change. You can take the entire Wikipedia document and run it through MD5. The output would still be 128 bits, and there's some math in there that makes that possible. The second thing to know about the second algorithm to call out is the Sha algorithm. And Sha is basically from the NSA, from the National Security Agency in the US. So there was Sha 1, and then there is Sha 2. And Sha 2, you can imagine, is just the newer version of um, Sha 1. And what the Sha stands for, these folks are pretty good at naming stuff. Secure hashing algorithm. So secure hashing algorithm, that's basically what Sha stands for. Sha 2 is the newer version of Sha. Now, even within Sha 2, there are different algorithms that you can use. So you can use Sha 2 24, there's Sha 2 56, there's Sha 2 03 84, which is a newer one, and there is Sha 5 32, and you name it. There are different versions of the Sha that you can use. And basically, what this 224 or 256 tells you, Sha 256 actually is a very, very common one, is that the digest size would be of character 256 bits. That's basically what it tells us. Now, another algorithm too out there you might find in the wild is the CRC 32, and CRC 32 basically stands for cyclic redundancy check. Okay, so cyclic redundancy check, very similar to the MD5. The cyclic redundancy check, very similar to the MD5 hash. In terms of that, they tend to be used for checking integrity of files, of documents, and that's just something to be aware of. So now, just to leave us, what are the key characteristics of a good hashing algorithm? There are some key characteristics of a good hashing algorithm. Number one, let's talk about the characteristics. If the hashing algorithm is good, it definitely want to have these characteristics. The very first one is, we'll call these characteristics of good hash functions. Number one is, it should be quick enough to be useful. If you're gonna go to a website and log into a website that's gonna take your password and hash that password to give you a hash or digest, so you can look that against a database, and that hashing algorithm takes 2 hours to run, no one is gonna want to use that. So you want a hash algorithm that's pretty quick, so you can put in an input, get an output in a reasonable amount of time, and it should be difficult to brute force. So brute force means I shouldn't just take that hash and be able to somehow use enough computation to figure out what the input was. Okay, you can do it with enough computing power. You can always do that, but the hash algorithm you choose should be complex enough to make it so that you can never brute force that. And then last but not least, depending on what you're trying to do, it should minimize collision. And a lot of people spend time, and a lot of literature has been written around this for how to minimize collision in hashing algorithms if the output is the same. And you tend to have collisions when you have the same output. So what is collision? A collision is when the digest is the same digest. So If I had my password, and a lot of people tend to use the same password, my input as through, and my digest gives me 0160185. Let's say that's the digest hypothetically. I shouldn't be able to go with a different input to say tech and be able to get the same digest 0185. That would be a problem. That's collision, and collision is really not good. All right. So your hashing algorithm should be sophisticated enough to give you the same fixed digest, which is what you expect, but there should be very little to no collisions. All right. Just to recap, hashing is something really, really, really useful for computation, and we've kind of gone through an amazing exploration here. So, what is hashing? Hashing is basically scrambling information. You take information, you want to scramble that in a way that's irreversible and consistent. So, a specific input would always give you a specific output, but if you have the output, you cannot detect what the input was. We use the analogy of a chick hashing. If you have an egg, you can have a chick. If you have a chick, you cannot go back to an egg, at least in theory, or not yet. We haven't figured out how to do that. So that's what hashing is about. It's used for a lot of use cases, for cryptography, for website security, for integrity checks. So if you log into a website, they're hashing your algorithm and they're saving the hash value. That way, if someone gets the hash value, they cannot figure out what your password is. If you send a file to somebody, you can have a checksum to figure out that the file that they've received was the correct file, and hashing comes into play. Lots of hashing algorithms to choose from. MD5 hash is really used for checksums with file sharing. The SHA hashing algorithm, very, very common. CRC32 cyclic redundancy algorithm is another one out there for checking integrity for files that are being transferred. A good hash algorithm should be quick, really fast. You can have a hash algorithm that's super complex, takes hours and hours to run, but it's not going to be useful in the real world because the example of a password check, you don't want to take 5 hours to validate the password for a user. Someone should not be able to brute force it. It should really be like an egg going to a chicken. You cannot go back from a chicken to an egg. And then you want to minimize collisions because if you have multiple inputs leading to one output, that could be a problem in hashing algorithm. You don't want a user with different passwords all being able to log in into the same system because the hash gives them the same value. All right, guys. So there you have it. Hopefully, this was helpful and give you some ideas on what hashing is and why it's useful. As always, you have been very awesome sticking and watching this to the end. We make a lot of videos like this. There's more coming. If you have any questions, don't hesitate to jump into the comment section below. Let me know your questions. I'll see what I can do. You have been awesome watching to the end. I have been through. I'll see you in the next lecture.